All right, so today's topic three. In terms of like the material on Canvas is kind of like just more deep dives into like Python basics. So it's going to be a lot of continuation of topic one. Let me get into the student view so it looks a little bit nicer. Like I mentioned in the homeroom, if you read like what I put as like topic priorities, I mean, you don't have to, but I would say from the top until user input and output in Python, that's going to be pretty important because that's the stuff that we're going to build upon, especially with Python. All of this stuff, I think, is a lot of repetition. We are going to get in depth into stats in the next phase. These are pretty like level one statistics. If you're not familiar with statistics at all, good to go through them. These are things that you might utilize in your first project. So I would deprioritize this stuff for now. But if like the words like mean, median, mode are not familiar to you, correlation is not familiar to you, then I do think that it's worth taking a read through. In terms of what we're going to talk about today at this study group, I'm going to talk about lambdas. Lambdas are a little bit confusing at first, but going to be very useful, in my opinion, in very specific use cases. So I'm going to be talking about the specific use cases in which we doing data science will see lambdas. We're going to talk about a few of these, and I have a bunch of examples here. And then we're going to come back to lambdas on Sunday when we talk about pandas, because lambdas is used in pandas as well. If you don't know what lambdas are at this point, no worries, I'm going to talk about it in a bit. And then we're going to talk a little bit more about dictionaries. So this is actually a dictionary that I took from one of the lessons. I believe I took it from, is it functions with arguments? I think it's that one, or using nested loops, one of those. It's the one with the soccer players. I believe it was also in the pre-work. I'm going to share some like tips and tricks on like navigating very large dictionaries, especially because big dictionaries is a pretty common data type. I will tell you, I have a student that's working on a capstone that has like a 2 GB large dictionary that he's working on. So it's pretty common to work with giant dictionaries. We'll actually see more of that when we get to like topic 9. And then I will introduce some of these like questions that I would like to talk about during our one-on-ones if you don't have like other questions. All right, to start, let's talk about lambdas. This example that we're going to be walking through actually is in our curriculum as well, but it's in the appendix. I didn't really mention this before because the appendix stuff is a little bit harder. But if you find that you want to get like extra practice on anything, the appendix has a bunch of sort of like extra practice, additional topics, and sometimes like summative projects. Different phases have different things in the appendix, but this is actually from analyzing Macbeth with pandas. We're not going to get into pandas today yet, but this code that I took from the start comes from the beginning of that lab. So to start, we're going to talk about lambdas. And lambdas, as I mentioned, used pretty widely. I would say more when you are doing a lot of like straight up coding. You'll see when we get into like more data sciencey stuff, we don't do a lot of like programming. We do a lot more like implementing. That doesn't make sense now, don't worry. But in the actual like programming part, that's when you would use lambdas more. And in my opinion, I do think that lambdas are used in more specific occasions when it comes to data science. And we're going to talk about lambdas in a few examples. Just for some context on this example, this is analyzing the Shakespeare play Macbeth in terms of like its word count. So if you take a look at that appendix lab, I think it has like a lab talking about, oh, make a bar chart of the most used words in Macbeth. I think that's like something similar to the prompt. And the context of what we're doing here is, actually, I'm going to walk through all of this real quick. What we're doing here is we're importing the text of Macbeth. And I'll talk about what this line means. This is actually something that we're going to use later in topic 9. So don't worry if this request.get doesn't make sense yet. We're going to get more into that. But basically what it does is it reads this text file. When you do a .text, and we can actually take a look at it step by step. Let's see. So Macbeth has this text. So let's take a look at the variable Macbeth. You can see it looks kind of messy. Some things that are pretty good to know about text. Whenever you see like a backslash means escape. And when you see an escape character, it sort of means that, like, you know, when you print the word, it doesn't really show anything. It's just more of like a proxy for a symbol. As an example, I know that \n means new line. If anyone has seen like HTML, this might look familiar. So if you see \n, it's like sort of like pressing enter on like a Word document. So the difference between this and if I were to, I wonder if this will work. If I do like print Macbeth, you can see that it actually formats a lot more nicely, a lot nicer. So all of those \ns, those I forget what \r even is, but anytime you see a backslash, it is the character that comes right after the backslash usually means that there's like an enter or a tab or not space, but yeah, it's just like another character. Okay, so Macbeth has this entire play Macbeth. So that's what that is doing. And we'll get more acquainted with what this means later on. Next, in order to sort of get a sense of what words are being used, we're going to use the .split string method. And if we remember the .split string method, it automatically splits a long string. So Macbeth right now is actually one really long string. And it's going to just split it based on where the spaces are. And so that's what words is doing here. So now words has a list of words. So as you can see here, I mean, there's still a bunch of data cleaning to do, and we won't get into data cleaning text too much right now, but you can see it has split the text into a list of words based on where all the spaces were. So it starts with like the project, Gutenberg's, blah, blah, blah. And you can see there's going to be a bunch of cleaning because there are all these like star characters. I think there's going to be, yeah, a bunch of these like other escape character things. Yeah, just a lot of data cleaning to do that we won't get into for now. The next step, this I would say is not a very commonly used way of doing this, but I do want to explain it just in case someone goes through the appendix and is like, okay, what is this function doing? So what's happening here, if we take a look at word counts starts as an empty dictionary. And then when we iterate through all of the list of words here, it's going to create a new entry in this dictionary and then count up each word. So if we take a look at word counts first, you can see that, all right, cool. We have, I remember this was that weird first thing in the list with some escape, I don't know what that is. And then you can see like the with 3 stars preceding came up twice. Of was used 395 times. And then you have all of these word counts. How this dictionary is being created is using this pretty neat get method. So this get method is pretty interesting. So let me pull up the documentation, Python dictionary get. Oops, what did I just do? Okay, let's see. The W3 schools one is always nice. Okay, so how does the .get method work? You do some dictionary .get key name, comma, value. So key name is a required argument, and then basically it's the key of the item that you want to return the value from. And then value is a value to return if a specified key does not exist. So this is a pretty neat way of using the .get. You can see for each word in words. So actually, let's do a smaller example. Let's do the example, I don't know. This is in, oops, should have typed this up before. This is an example. This is neat. All right, so let's do example here. So if I do the same kind of function on example, so let's just do this. And let's do for word in example. And then let's create a different dictionary example counts equals dictionary. And then let's just update this to make sure example counts. Okay. So what it's going to do, it's going to loop through example. So it's first going to see, all right, the word this. And then we're going to take the word this and update the dictionary. So right now the dictionary is empty. And if you remember the way that we just add a new key to a dictionary, we use something that looks like this. It is this syntax, but less complicated. So to add a new key dictionary, we always do dictionary key. Dictionary key equals to value. So here it's calling example counts dictionary. Word is going to be the key. So in this case, this, the word this is going to be the key. And then it's going to assign it some value. So when we start this dictionary out, when we start out this loop, the word doesn't yet exist, right? This dictionary is completely empty. So when I do .get is going to return 0. This part is pretty confusing, I know. So like if we do example counts .get, and if we do this, comma, 0, oops, I have to run. Let's create this first. All right. If I do .get on this equals to 0, this comma 0, it actually gives me 0. And it gives me 0 because if the specified key does not exist, it's going to return you 0. So let's just run this cell real quick. So the first time when you run this and it's looking for this, is going to give you that the value with this is going to be 0 to start. And then here we're assigning it 0 plus 1. So then after the first iteration of this loop, the dictionary is just going to have this ... 1. It's going to do the same thing for the other words. When it comes to this again, let's see, I ran this already. So let's just see what happens. I ran this already. So this happened twice. This word occurred twice. So therefore, if I just do a .get, it's 2. So what this is going to do is, as you can see, it's just going to keep adding 1 each time it occurs the same word again. Does that make sense? I do think it's I would say the .get method is not used super often, just because, you know, this is pretty much the same as doing example counts this, right? And I get 2. The .get just gives you the functionality to be like, all right, well, if this key doesn't exist, add a 0. Because let's say later in the text, I have a brand new word. So let's say I have like the word Python. It's going to give me a key error. So the difference between doing this and that is that if I were to get the word Python, this would give me a 0, where this throws me an error. So just some fun functionality. I honestly don't use the .get too much, but it's a good one to just be aware of.
So is it assigning that variable to be 0 if there's nothing there?
That's right. Yep.
Okay.
Yep, that's right. And in this case, it's assigning it to be 0 and then plus 1. So it actually starts it as 1. Any other questions regarding this? I think this, again, not a very widely used method, but yeah, good to know. And if this is confusing now, I would say that I had this lab when I was a student. I saw it. I was like, yeah, no thanks. I came back to it, like, honestly, the first time I had to teach it again, and then it made so much more sense. So yeah, just for you all to know, like, how important is understanding this part. This is not even the main point of what I wanted to talk about, because I want to get to Lambdas. All right, so this process of doing these example counts, we're going to do that for the entirety of Macbeth. And so you can get rid of this for now. Okay, so now we have word counts, and word counts has all of the words that ever occurred in Macbeth with the count of how many times each word occurred. And this is useful for that lab because you want to get the most common words. So as you can see here, what I have is I'm actually converting that into a list. Why we convert it into a list, it's just usually easier to sort a list versus a dictionary because lists are ordered, dictionaries are not. So what we're going to do is we're actually going to look at counts and actually have that down here. Cool. So now if you remember, I did word counts dot items, and we talked about this last week. And anytime you do dot items, it turns a dictionary into a list of tuples. So here's what we have. So if this is our data that we have right now, and we wanted to get the most common words that occurred, how can we sort this? Like, how do we want to sort this? Because it's word and then followed by count. We want to sort it by this second element of the tuple, right? In this list of tuples, we want to rearrange this list such that, you know, the element with the highest number in the second element of the tuple will be at the top. And this is actually what was provided in the solution, which honestly is I think it's the best way to do it, but it's a little bit confusing. Here, and we'll break it down in a little bit. Top 25. This is what it gives. I mean, I don't think it's very surprising. The most common words are like the, and, of, to. Whether you want to clean those out, that's like a later thing that we'll talk about. But how do we get from this to this? We use this pretty intense looking sorted function, and I want to break this down. All right, so to break this down, sorted is a built-in Python method that just helps you sort things, right? If you don't tell it exactly how to sort something, it'll still sort it for you. So if I were to just do sorted and then counts, you can see that, well, I feel like it's not surprising, but it sorts it alphabetically because, I don't know, it recognizes that the first element of the tuple, usually that's what you want to sort things by, right? So it actually sorts everything alphabetically, which is great if you need the list like that. But thank goodness that with other arguments, we can sort of teach it how else we want to sort it. Maybe you want to sort it by, well, in our case, we want to sort it by the second argument. And that's where Lambda comes in. Lambda comes in here. As you can see, we're giving it a key of which to sort by. So let's look up Python sorted real quick. Ah, nice, the W3 one. All right. So here, when we're sorting something first, you want to sort an iterable object. You give it the key, the function to which to decide the order, and then whether you want to reverse it or not, and like ascending or descending. And we'll see that we have that value as well. Oh, before that, in key, you can actually see that it says a function to execute to decide the order. And that's where you can't tell it like, well, that's how you tell it how to use the second element of the tuple. And so we'll get into more details of Lambda in a little bit, but how this way they did it is they did Lambda x colon x index 1. How a Lambda works, Lambdas are actually used pretty commonly in this field called dynamic programming. Dynamic programming is sort of in a way that, you know, Lambda actually is a function, but it's a function without defining a function formally. Like this topic actually talks about, you know, you do the def and then function name, arguments, dot, dot, blah, 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 return all that. And that's a formal way that we do in Python to define a function. Sometimes a function is so little and you only know that you need to use it once. That's when you use a Lambda. And Lambda basically tells you, Lambdas are good for iterating when you know that you want to do one thing for every element in some sort of collection. That's usually the case where Lambdas are used. And in this case, we want to sort something. The thing that you want to sort is usually iterable. So we're going to do here what this means. And this syntax really does take some time to get used to. I personally didn't really use Lambdas until like a few months into my coding journey. But it does come up a little bit in the solution. So just in case you come across, I do want to explain. So the syntax of Lambda, it always has a Lambda, some variable, and then a function. So Lambda always works as it's the word Lambda, variable, and then some function. And the function works on then the variable is always part of the function. So this variable is actually going to, similar to a for loop where you have that temporary variable, it works very similarly to that. That variable will point to everything in the iterable object. So in this case, the iterable object is a list of tuples. And so here, this variable x is going to temporarily point to each tuple in the list. And then because here you're just telling it, how do I want to sort? We're going to do x index 1 to just point to the second element in the tuple. So yeah, x index 1 just points to the second element in the tuple. That's how it knows to sort it by the second, by the word count, not the word. The other argument here is reverse equals true. And that just sorts it by descending order. And then here I'm just taking the top 25 words. This is just slicing. So if I actually take that away, you can see that I actually have all of the words in all of their counts. But because in this case, I just want the top 25, I'm just going to take top 25. Questions about this? It's a little bit confusing, but yeah. Questions?
So yeah, I just had a quick one. So for the top 25, I saw that like sorted, you have the parentheses, and then for when you're just slicing, you have the brackets. So you don't need to include that within the sorted, right?
That's
like,
right.
Okay, you don't want to put that with the sorted because because you are slicing. It's different from I'm trying to think of a word here, but I can't think of it. But
yeah. So one way to know, because it is sometimes confused, like where do I put this? Because sometimes you might think, all right, yeah, I should put it like in here, right? I think that's like something that you just like naturally would think to do, because this kind of looks like you're just adding something to the end of it. So one way to, that's why I sort of like to, when I code, I like to write things out in pieces and like break it down one by one. So, before even thinking about slicing it, I have to sort it first, right? So I know that sorted gives me this result, this long result. Something that I think you should also get used to is the result of this is also its own data type, right? So this entire thing that's highlighted returns you a list of length. I don't know how long this is. Let's just say it's like 100. So this entire thing is the list. And when you want to slice something, and if I had like a list, I don't know, let's just say this is the list that I had. Oh, cool. I want a simpler example. Let's do, list of word counts. There we go. And just as an example, this is our list. So if it's just a regular list, we always just do the variable followed by the slicing. Jupyter Notebooks does that sometimes, and they think it's helpful, but yeah. There we go. So you always want to slice after the thing that you know is the list itself. If you put the slicing inside, it will try to, interestingly, I think it will try to slice the word true. There we go. Because it looks at what's directly preceding the square bracket. And then it'll say Boolean object is not subscriptable. And subscriptable is sort of like iterable, or like you're trying to index slice or something like that. So that's what it's saying here, that if you do something like this, it looks like you're trying to slice out true. So usually if you see something like that, a type error, I don't know. This particular example, you can sort of, I guess, work backwards to see, all right, why is it telling me the Boolean object? I look in here and say, what is the Boolean object? Oh, it's true. Right, I can't slice the true. Figure out what is making the list first, and then slice from there. That help?
Yeah, it did. Thank you.
You're welcome. All right, anything else?
Yeah, I have a question. I know you said that the 1 in the next to the X is in the brackets is the index number.
That's right.
Can you like explain that a little further?
Yeah, absolutely. So each X points to a tuple. And it points to basically each element in the list. If I were to do X0, it's going to see, all right, so tuples are sort of like lists in which they are ordered. So when you are indexing through a list, you start like 0 and then 1, right? And then same with a tuple. So this would be the 0th element. Oops, the word will be the 0th element. The count will be the first element. So if I were to do x0, it'll actually sort by the word instead of the count. And because I have it at reverse, it's going to sort by that. And to get it to sort by the second element, which is the first, which is like the index number 1 element, that's where the 1 comes from.
Oh, okay. I understand.
Awesome.
Thank you.
You're
Yeah.
welcome. Anything else? Cool. All right. Let's talk about some other use cases of Lambda. So basically for this lab, you just take this result of top 25 and you like make some graphs out of it. Some other instances where you use Lambdas, 2 instances that I personally use Lambdas a good bit is through maps and filters. We're already at 42. Wow. Okay. So let's just say I have this list, really simple list of 1, 2, 3, 4, 5, 6. Mapping, and this you might see in some solutions. I know some solutions, they have these as well. Maps and filters are pretty common. But here we're utilizing Lambdas to do some sort of quick function on this list. Let me just run these and let me run this and we'll see what happens. I run this cell and what comes out is 3, 4, 5, 6, 7, 8. That's because the function that I have here, this Lambda function that I have here, is saying for each x, let's do x plus 2. So that's the function part. There are kind of like 3 things going on here. There's the Lambda function, there's the map, and then there's a list. So let's go one by one. So the Lambda is just saying, all right, for each x, do x plus 2. The map part is what tells the map part tells it, all right, this function, what do I map it to? What am I mapping this x plus 2 function on? And so map, if you like break it down here, has 2 elements. So map has first the function that you want to map, and then it has this L. So L is this list here. So it's saying, all right, map this function of x plus 2 onto L. And then we have this list, and I'll show you why we need this list. So let me just copy this part out. If I just do this map here, it's kind of annoying. It's a Python thing, but Python, we'll talk about it like in phase 3, but Python deals with a lot of like objects. And so these map objects are something that you can't really see when you like execute the code. So this map object is here. It doesn't look like anything. It just says that this is actually where in your computer's memory this map is being stored temporarily, which is pretty neat, but not useful for our purposes. The function is actually done. They've actually already done this like x plus 2, but we just can't see it. To get it into a format that we can see it, that's why we have to add the list around it. So yeah, it's just 3 things going on. You have the Lambda, you're mapping it onto L, and then we have to coerce it into a list such that we can see the result. So that's mapping. I would say play around with like different things. If you want to do like x plus 4, it goes for 5, 6, 7, 8, 9, 10. In a very, very similar vein, you have filter. And filter works exactly the same as map, but instead of doing some sort of function, you are filtering your iterable object. So here you can see that I have my Lambda again, and here I'm using a condition. So instead of a function, this Lambda, I'm doing a condition, which is pretty neat because a Lambda supports not just like a function that I want this to act on this. I can do this condition. And basically what it does is it tells you whether it's true or false and only keeps what elements return true. So here I'm just looking for even numbers. You remember this % sign is a modulus. And then basically I'm just looking for the even numbers. So same thing, I have my Lambda function. Instead of map, I have my filter. So what I'm saying here is apply this Lambda filter onto L. And then because filter actually does the same thing as the map, you'll actually get this similar result here. Well, I'll say like filter at whatever address. And then to just see it, you got to coerce into a list. I would say filter is probably more useful because map, I'm actually right now going to show you another way to do map that might be even faster. But questions about this part?
Are you able to use truthy and falsy values for Lambda filter?
I believe so, yes.
Okay.
Nice. All right. Hopefully we don't have to speed too much through this, but this is the last thing I want to talk about. List comprehension. I don't remember if the pre-work has this, but list comprehension is a really, really neat way of making lists from other lists. There are a couple ways to do this. So let's just say I wanted to create this list, right? This x plus 2 list. I have 1, 2, 3, 4, 5, 6, and I want to create 3, 4, 5, 6, 7, 8. Of course, in real life, you're going to have a little bit more complicated functions, but let's just do this for now. Quick way to do this is we can do that in a for loop, right? We can do for x and L, append x plus 2. I think this is the way that we were doing it in the pre-work, which is, I mean, it works. 3, 4, 5, 6, 7, 8. As we saw a little bit earlier, we can do this with a map lambda, right? Map lambda got us the exact same result, sometimes even nicer because, you know, it's in 1 line versus this is 3 lines. So this is also pretty neat. Even quicker way to do this is something called list comprehension. And list comprehension is actually a very, I think it's a Python, I know it started with Python. I'm not sure if other languages have this now, but it's a very Pythonic thing. And I think it's like a really neat, sometimes it's a little bit more easy to see what's going on in a list comprehension. And the list comprehension for this is this line right here. And it looks pretty short, but let me just break it down and so that we can recreate this in the future. If you want to do a list comprehension, you're actually just doing a for loop within a list. And so the way I like to create list comprehension is I actually start with the end part first. What am I iterating through? So I start with for x in L. And then in front of that, I just do what function I want it to do. Here I can do x for x in L. That'll give me 1, 2, 3, 4, 5, 6. Here I'm just doing x plus 2 for x in L. This will give me 3, 4, 5, 6, 7, 8. So as you can see, we did the same creating of this 3, 4, 5, 6, 7, 8 list in 3 different ways pretty much, right? We had this for loop way. This is technically also a for loop, but it's called a list comprehension because it's done inside a list. And we also did it this map lambda way. I will say that I wanted to force myself to practice Lambda, so I was doing this a lot when I was learning. And then now I pretty much always do a list comprehension just because it's, I don't know, fewer characters to type out. And which method you choose to use, it really doesn't matter. Actually, if you were to look at the code efficiency of these 3 methods, same efficiency. They're just doing the same thing, just in different syntaxes. And then there's no like better way to do something. Some would say that this way is just clearer sometimes. So the way in which you choose to code something, let's say there are different methods to create this list, the way that you choose to go forward with it is actually known as your syntactic sugar, just like your coding style. So that's something that you just learn to develop over time. So it really doesn't matter which way you choose to do it. I just think that it's my opinion that like if you're coding majority in Python, good to get used to list comprehensions because sometimes I do think it makes your code look a little bit cleaner. So that's really quickly what list comprehension is. You can see that instead of doing like, you know, appending elements to a brand new empty list, you're just creating the list all at once. So this is repetitive, let's get rid of this. Pretty neat. You can also do it for dictionaries. For dictionaries, this is probably not the best example, but for X and L, I can create like a key value pair. So let's say I want the key to be the number itself, and then I want the value to be the number plus 1. Or actually, let's just do this so it's a little bit more distinct. So let's just do string will be the key, and then X plus 1 to be the value. Although the result's going to look a little weird, but whatever. So this works too. So you can see that it's from L, it's iterating through L and creating this dictionary, which is pretty neat. I do this sometimes as well. something that you can add on to list comprehensions. You can also add in conditions. So it kind of works like a filter. Here you can see I have the same list from before, x plus 2 for x and L. But at the end of it, it took me a while to remember, do I put the if statement before or after? So it's, honestly, I just do like trial and error, but you put the if statement after the for loop. And I just do an if statement if x modulo 2 equals to 0, and that produces my even number list. So yeah, these are just like little Python list creating, dictionary creating quirks that you can feel free to like get acquainted with if you'd like. Questions about this? Cool. I would say like times when you can try to use list comprehension is if you see that you have to make a list from another list, or if you need to make a dictionary from a list. Mo, I think I saw you come off mute. Do you have a question?
Yeah, no, I just had a comment. I think this
Yeah.
list comprehension is more simple than the for loops and the Lambda. Just like you said, it makes it like more cleaner.
Yeah, it is super. I think it's just really elegant. And it reads easily as well. Because I think like, yeah, I'm doing x plus 2 for every x and L, rather than having to remember, like I was really bad with remembering colons. And so this has no colons. Yeah, list comprehensions are really neat. I wasn't taught this during the boot camp when I was doing it. And like when I learned, I was like, where has this been all my life? All right. Cool. With our remaining time, I just wanted to talk about this soccer dictionary and like my tips and tricks for navigating a giant dictionary, just because we'll be navigating with big dictionaries starting topic 9, going for the rest of the course. But we're getting some examples of dictionaries now, and I think is a good idea to start to practice. So it looks like a big dictionary, but in comparison to some of the dictionaries out there, not very big. And actually, this is a list with 2 big dictionaries, with 2 like dictionaries within a list. So really common when you're given like a fairly relatively large piece of data, you want to explore it. When we get to our project at the end of this phase, we'll actually talk a little bit more of like data exploration and how you do that. And you can like, create visualizations to aid in that process. You can do a lot of like summary statistics to learn just like overview of your data. But sometimes you just don't really know where to start. And I think that's the case, especially with dictionaries, because it just looks like a lot of words. Some of the key things that I like to do when I start messing around with some new data that I get is literally use some of the Python built-in functions like type and length. So for example, I see the gigantic thing. Sometimes I don't even notice like where do the brackets start and end. Honestly, the brackets starting and ending, that's something that is very, very hard to read for me. So what I do is I print type. So you can see here, I printed a bunch of things all at once, but the first thing here, I was like, let's just see what soccer match is. So soccer match turns out to be a list, which my instinct would be it's a dictionary, but turns out it's a list. And the list, let's see how long it is, length of 2. So all right, it looks like there's a lot here, but there's technically only 2 elements in this list. And then usually what I like to do is I either look at the first or the last element of a list just to like get down into it. So here we see that, all right, soccer match 0 is this whole thing. Cool. What type is it? It is a dictionary, I think. There we go. Soccer match 0 is a dictionary. Oops. What was that? I didn't know I had that functionality. Okay. Soccer match 0. So soccer match 0 is a dictionary. And if like this fairly large thing is a dictionary, what I next like to usually do is explore some of the keys, because the keys usually tell you what information is in there. So here you can see, all right, cool, home team, away team, blah, blah, blah. This becomes more relevant later. We're going to see these giant dictionaries when it comes to APIs. In brief, APIs is just a way to just get data from the internet. And sometimes they just don't structure it in a way that's immediately obvious where exactly is the data that I want to use for like my project. So in this case, it's like, all right, I know I want to do this project on like players, for example. And so, all right, there's this key players. So because I looked at dot keys, I can explore each key. Actually, let me do that separately here. Maybe I like explore each key separately to see what's in each and which one is going to have information I'm going to use. I would say in your notebook, especially when you're starting to code, is good to have a lot of like extra cells that you're like reading, just like random outputs of your data, just so you can explore and get familiarized with what data you're playing around with. So very normal to have like a bunch of messy cells with like all of these weird outputs, completely fine. That's just like one piece of advice I have when you're working with fairly large data types. So here I have my keys and I'm just looking at players. Maybe I want to look at, all right, what's the home team have? Cool. Just a true false. Maybe I want to use that. Maybe I don't. So yeah, that's just my advice with playing with dictionaries. Make use of the type so that you know, okay, do I want to like iterate through it? Do I want to look at its keys or values? Look at the length just to see like, all right, if I'm expecting like data on how many players are there in a soccer team? 11? Yeah, if I'm expecting like 11 players, but here I only see like 2, is this the information that I want or not? So that's like a good way to like sort of get a sense of what you're looking for. And yeah, usually if it's a really long list, or if you know that's a list of multiple things and you just want to look at one of those instances, I always like to index 0 or index -1 to see the first or the last one. Questions about this before I talk about like the mini like homework assignments? Cool. So for the upcoming 101s, either this week or next, depending on when your 101 is, again, optional, but I highly recommend it. I put 2 questions here, and let me just tell you, these 2 questions, you can do each of these in many, many different ways. So here the question is count how many players have even shirt numbers. And then here I write a function that appends player names and shirt numbers to a list until the sum of shirt numbers reach 100. There are many different ways to go about these functions. Feel free to work together to figure this out if you'd like. I actually really, really encourage it. So yeah, I know in this study group, we didn't really talk about like how to write a function. I feel like that information is pretty well documented in the Canvas labs. So feel free to go through those, but very important to get used to writing functions. Here, just a suggestion, you can try using a while loop or a for loop with a break or a combination. And also additional tips I want to add for this is your one function doesn't have to do everything. You can have multiple functions that achieve the same thing if you think it's easier to break it up. Feel free to get creative. One quick thing is if you notice that if I were to look at players over here, players here, I have 11 players, but these players are only from the home team, I think. How do I do it in a simple way where I have all of the players from the home team and all the players of the away team? So yeah, just something to think about. Happy to talk about how you went through it. If you get stuck, ask each other, ask me. But yeah, I would love to talk about these couple of questions when we have our 101s. Here, just the second half of the topic. Again, we're going to go through all of this in phase 2 and not the most important for right now. So yeah, I would say if you want to focus on something, focus on like writing the functions. But cool, we are right at time. Any questions to close out?
Yeah, so these 2 questions are they part of, they're not in the Canvas labs, right? They're in the study group.
Yeah.
Okay.
They're not in the Canvas lab, but feel free to just take these questions, and there's one lab with this same data set. So you don't have to like do it on this notebook if you don't want to like have too many notebooks, I guess. So feel free, whenever you get to the lab with this data set, you can just add it to the bottom of that notebook. Oh, and by the way, I don't know if oh yeah, go ahead.
No, go ahead, sorry.
I was just gonna say like a quick shortcut for adding cells in your Jupyter notebook is make sure that this is blue, because when you're editing code, it's green. When it's blue, you can press A to add a cell above or B to add cells below. And that's just a quick shortcut that I think might be helpful. Cool. Any
Uh,
yeah.
So should I refork your repository and then clone it again, or all right?
Yes. Yes. Unfortunately, you
Okay.
cannot refork something. You would actually have to go into your version. Let me just see. I think I can see who forked it from here. So Mo, I can see that you forked it here. And this is what you have. To refork it, you have to delete and then refork. So if you go onto yours and go into, where did they move the settings button to? Let's see, is it maybe actions? No, they recently reformatted all of GitHub. So I'm not too sure where everything is, but see if you can find there's like a setting somewhere that you can delete this.
It's right next to the insight button on my GitHub. I'm not
Okay.
sure what it is
Oh,
for you.
maybe because this is Mo's version, so I don't have the option to do it. But Mo, I think on yours, if you see like a settings button, you can delete your repo and then you can refork it from mine.
Okay, so all right, I think I see it. All right,
In any case, we can also work through it on our one-on-one if you need help, or shoot me some screenshots, or if you want, like I know you have your one-on-one book this week, but if you see any other slots, we can just feel free to book. Yeah, that goes to any of you. If you're like really working through something, you want to talk about it, if you see additional slots on my link, feel free.
Oh, great. Thank you.
You're welcome. All right, I gotta hop on to the next one-on-one, but I will see you all tomorrow. We'll get into NumPy and pandas, and throughout the rest of today or tomorrow, if you are having any issues with the repo, let me know, because that first thing, every class I do miss. I mess that up, and I haven't figured out the root cause of it yet, but yeah. All right, I will talk to you all tomorrow. Have a good rest of your evening, everyone.
Have a
Thank
good
you.
night, guys.
Bye.
Thank you.
Bye.
Good night.
Bye.
Thank you.